Hello everyone and welcome back. So now I'm gonna take a look at how we're gonna create something like this. So I have a variety of designs here. This one and this one is what I'm gonna be focusing on. These guys are a little bit more intricate. Maybe not so much this one. This guy is a little bit more intricate to have a 100% procedural system for it. So I'm gonna do this and hopefully teach you guys some new things. And I'm going to show one quick thing about the copy SOP, and honestly I do not remember if I explained what a copy SOP is, so I'm going to do that. I'm going to create a circle. I'm going to change it to OpenArc, and I just need half of it. And let's add some points. Cool. So let's copy a cone. Tube, and this tube, I'm gonna make it smaller height, and let's make it a cone. Cool. Let's increase the circle size. And I'm going to use a copy to points. This takes in any input geometry and copies it into points. So these are my points. Let's delete the geometry and just see the points using an add. So these are the points. I want to copy this cone to the points. That's working. Let's increase the scale. I'm going to put down a transform and let's scale it. And you can see they're not aligning properly. We're expecting them to be pointing in an interesting way. And the reason for that is because they don't have an orientation to follow. So what we can do is we can compute a vector that travels along this curve, follows the path of the curve, and use that to align these guys. So the way to do that is using a polyframe node. So it has a weird name, but it computes the tangent. We can compute the tangent of this curve at each point. You can see here it's computing the normals. We're not interested in the normals. We want the tangent. Okay, so I'm gonna untick this, and instead of using this tangent name, I'm gonna store this result of this operation into the normals. Okay, and let's take a look. You see now, it's hard to see. It's just take a look at the points. This is the tangent information. We're storing that as the normal. We can type in anything here, and we'll create an attribute. But to save us some hassle, I'm going to use the normal. So if we go back now, you see the cones are aligned to something. But they're rotating, they're swirling as they go along. We don't want that. The reason for that is because they need another vector. The normal defines their orientation, but we need to define something called an up vector. And this is just a value that tells it where the up vector is. So I'm going to create a wrangle node, or actually let's use an attribute create. Okay, we need to create a vector called up, and it's a vector attribute, and its value is 1. I'm going to set it to point in the y direction. Let's see, and that should align them. Sorry, it's not. Yeah, I was creating it on the tube. It should be an attribute on the points. So I'm gonna move the attribute create here, and it's fine. Set it to 0, and let's take a look at the attributes. Now see, I'm opening the spreadsheet every time, and I want to make a shortcut for that. This is a side bonus. To open the shortcut menu for any node, you hit Control Alt Shift and click. And this will bring the dialog for it. And I'm gonna double click here and hit Shift B, and that's my shortcut. If it has some mapping, it will inform you. So I'm gonna hit apply. It has no mapping, so if I do Shift B now, it gives me this spreadsheet. This did not used to work before to open this guy in a separate spreadsheet, so it saves a lot of time. Cool, so you can see the up vector, you can see the normals, and my cones are aligned. Great. Now, what if we wanted to create our own vector? Okay, instead of using this, I wanted to create something else. But what can I use in the case of a circle? Well, if we think about P, the position of each point, it's a vector that moves it from here all the way here. That moves this point from here to here. Same goes here. So if we take the position and plug that into the normals, we should have vectors facing outward from all these points. So let's do that. Let's move these guys here. Let's create an attribute wrangle and use vex this time. So it's very simple. I'm gonna say v at n. I'm gonna create a vector attribute. At is to create, and the attribute name is n, and it's equal v at p. And the position always exists. I don't have to prepend it with a p. And you can see now it's giving me this vector. And the reason for that is because that's what p is. It's a vector that moves the points from 0 to their current location. And this is actually a better vector because you can see it's perfectly distributed along these points. Let's connect the attribute wrangle here, and let's take a look now. You can see they're all facing aligned together, and I'm going to rotate this because it needs to be aligned to a specific orientation, so I'm going to simply rotate it, and now we have them facing the correct angle. So that's basically how the copy swap works. You have points, you copy geometry or anything onto them. They respect the n and the up vector to align themselves properly. Cool. We'll see where that comes in handy. And you know what? I'm gonna stop here and we'll continue in the next video.